All right. So let me flip back over here. I have a few poll questions as well that are more about this talk. I'll give you the quick intro. Thanks everybody for joining us here today. This is a little there is a little bit of DevOpsiness to this because of how it deals with Docker and Kubernetes, but it is more for the dev side of the world to help you figure out how to wind your way through the sometimes treacherous path of distributed application development. So yeah, I'm Jess Likens. I'm a cloud architect. I've been doing technology for forever. Um, if you want to know a little bit more about the boring stuff about me, you can head over to my site. I represent Polaris Solutions in a lot of these talks, so I'm doing that here. We're a application development shop based in Chicago and St. Louis. There are a lot of folks like me there, so if you want to talk to nerds, you can get a hold of us. Um, Before we get started, though, I want to make sure that we're all on the same page about what a distributed application is. So before, like I said, before I would dive in, um, when you think of a distributed application, you may think Docker or Kubernetes, or you may think Azure, you may think a lot of different things. But in the context of this talk, a distributed application is just something with multiple nodes that go across a network layer. It could be, a front end to a microservice to an event bus, whatever it is. So it's not like specific technology based for what a distributed application is. So I just wanted to kind of level set as like that's what we're talking about when we're talking distributed applications. So I have a couple of questions that I want to you guys to answer for me, so I can tune this more towards where the audience is with respect to distributed applications. So if you want to hop over here real quick and put in code 668 you should see hopefully this. So I want to know how familiar you are with what I just called distributed application development, whether it be two nodes or 20,000 nodes. Are you in a it's all I do space, or not at all space, or are you somewhere in the middle? I'll just give you guys a couple seconds here to answer. Good. We've got some advanced folks in here. That's good. A beginner. That's good too. All right. So we're sort of in the middle, which is good. Nice bell-shaped curve. Nobody's in the it's all I do column, which is no one's ever answered that, so no one's ever that confident that this is all I do. So that's cool. The next question is, how fluent are you with the idea of containerization? So Docker, Kubernetes, et cetera, et cetera. That's a very open-ended question, but just kind of evaluate yourself as you can.
How many people have answered, I invented Kubernetes?
Again, nobody's ready to go to level 4 on these, which is probably good, because that would mean I should just turn over the talk to them. Hey, we got one. All right. I'm retiring. Someone else take this over. Okay, so we're a little bit more packed around the tinkering space in here, so that's good. And then the last question is, this is open-ended. I like to ask this one. If you're in a distributed app space, just briefly, like, what are some of the challenges you face today with respect to anything? Code, configuration, deployment, whatever it may be. Security and complexity, yep, those are big ones. Any other ideas out there? Any other challenges? I like that it's security, period. It's like security, period. Debugging, yep, that's huge. That's hard, right? Automated deployment's tough. That green one's kind of cool. The decision makers are short-term thinkers. Isn't that the truth? Isn't that the truth? Server discovery and versioning, yep. Data access. Deployment failures. And configuration. All right, these are good. So I hope to be able to address a lot of these. I don't think I can help with that one in the middle. I wish I could. Sadly, I don't have that magic wand. Oh, what's this one? I can't read the bottom. Oh, there we go. Are challenges related to taking that legacy application, deciding whether to help it make it with distributed has? Okay, that's fair. And hopefully you might get some additional items to add to your decision matrix for that one there. Okay. So let's get back over to. So first, we're gonna hit some more slides. This is not a a PowerPoint demo. I just want to go through a couple things to level set here. So just to make sure that we're all on the same page. Distributed applications come with power and they come with pain. The power is kind of in this space here. There's a lot more that you get, but essentially you get the ability to scale nodes that need scaling. You can scale your business layer independently of your web layer, things like that. You can reduce latency by introducing things like, instead of going from a polling architecture, you can go to a push architecture with a service bus. You get better fault tolerance by being able to have more redundancy within your different layers. You get the ability to plug and play things, like you can plug your backend into all sorts. This microservice can feed any number of applications, and then you also can drive towards an event-driven architecture where nodes can talk to each other through an event bus and not have to know about each other. You don't need to know too much about any of these specifically. I'm not trying to sell you on distributed applications. They are powerful. That's kind of where we're headed, but this is what you get, but they are complicated. And that's why we're here today. We're here to talk about you guys hit, I think, most of these. And I think, complexity is a big one. When the more nodes you have in your system, the more complicated it can get, and you can get all sorts of hairy spaghetti going on in there. Security is more difficult because not only do you have a lot of other different sort of nodes in the system to deal with in their platforms, but also they can each be attacked differently. The deployment's hard because you've got 20,000 moving pieces now instead of one giant monolith. Infrastructure costs is a big one. If you don't know what you're doing in a distributed application, you can certainly run up your cloud bill, for example, pretty easily. And then finally, diagnostics. That's similar to some of the callouts at the beginning where we talked about, like, people were concerned about debugging and monitoring. Diagnosing and monitoring a distributed application requires you to have visibility into tons and tons and tons and tons of things. Monoliths are much easier to monitor. So that's where Thai comes in. So Thai is the brief history of Thai is the brainchild of the .NET group at Microsoft. The story goes that in late 2019, a couple of the guys on that team were working on some microservice stuff independently, and they decided that the Microsoft way of handling distributed application development isn't great. It's painful, right? If you're in this space where you have lots of microservices that you have to deal with, for example, it's hard to debug those. It's hard to tie them together. It's hard to get a development workstation up and running in that environment. It's just a big pain in the butt. So two of them went off and independently developed something behind the scenes that wound up coming back together into this thing called Thai. And if you're interested, the name Thai is another nod to the nautical theme that Docker and Kubernetes have. Thai is it's actually a term related to sailing that has to do with literally tying a knot. So the idea behind Thai is to sort of tie things together. So if you're interested, if you do a quick search on Thai in Videoland, if you find one of the the earlier videos from last year, they talk about where it comes from. But ultimately, it's designed to do a couple of things. So it's designed to figure out what services your applications need automatically without you having to cram them together. It gives you super easy access to Docker containers without you don't even have to understand what Docker is. It gives you a really cool out-of-the-box dashboard to see what your application is doing. It gives you basic, easy Kubernetes deployment to any Kubernetes cluster you may have. And the polished final version will be shipping with .NET 6. So that point in particular is important to point out here because it is currently in experimental phase, I believe is what they call it. But this is something they've committed to, and I've actually asked them recently, hey, is this still happening, guys? I haven't seen a lot going on. And Glenn Congdon is one of the evangelists for this product, and he's like, basically, this is what he said. they had some other stuff coming up, but it's still happening. So don't be afraid to use this. Additionally, if you do use this, don't be afraid of getting locked in. There is no vendor lock-in with Thai. Thai is simply some glue that lets you do things more effectively. But if you go down the Thai rabbit hole, you can get back out pretty easily. So don't be afraid to go ahead and bring this into your world. So what does Thai solve? It doesn't solve security, it doesn't solve costing, but it can help solve complexity deployment and diagnostics. So we're going to run through those things. In particular, it also, from a local perspective, it helps a lot with debugging. So the way this is structured, the demos follow a miniature version of a company's journey through startup, through the complexity that the business starts bringing in, all the way down through we need to really graduate to a distributed structure, and how do we deal with the pain that goes along with that. So some of the initial demos are really just table setting. So I'll go through those quickly, and then I'm gonna. This is where it starts to get interesting, where we can talk about how to do things like automatically pointing from service A to point B, and automatically doing distributed tracing and things like that. Spooling up databases and tearing them down without doing anything other than putting a few commands in your YAML file. All that stuff we're going to go through here. I will say that right before this, I broke my AKS ingress, and it takes a while to deploy one. So I can show you the deployment to Kubernetes, but I can't show you the publicly facing version of it. So I apologize for that in advance. It's still, the point will still be driven home, but the sort of the payoff moment where you can all hit it publicly isn't available right now, because it takes 1,000 years to provision one of those in Azure Kubernetes service. And then finally, this one down here, I think that's the big payoff, where I want to show you when you get to the point where your organization has 1 million microservices, those are going to be in their own repositories. They're going to have probably their own teams developing them. If you are in a place where you need to use more than one of those, how do you handle that gracefully without driving yourself crazy in your local environment? So that's kind of how we're going to progress through this. So any questions or comments or concerns about where we're headed before I take us into code? Let me pull up the chat window here. I don't have that open. All right, doesn't look like it. Okay. If you want to follow along in code, you can hit this URL. I should probably, oops. Guess I can't copy it from presentation mode, but all the code here is there. I tried to give as much love and detail to the readmes in each of the examples as possible, so there is a lot of explanation in each one about what's going on. If you jump in halfway through, just be aware, like I said, they do progress. So if you start at number 5, you're probably gonna at least go back up over 1 through 4 just to understand how we got to 5, because they do kind of build on each other in terms of the story we're telling. So that said, let's get the heck out of PowerPoint and bounce into code land. So just to set the scene.
Hey, Jess, if you're speaking, I don't think we're hearing you. No, we can't. Can you hear me?
I can hear you.
Yeah, I can
Okay.
hear you too. I
I
just
hear
can't
you
hear
too.
Jess.
How about this microphone? Can you hear me now?
Yes, I can.
Yes.
All right.
Yes.
Cool.
Can you go back a little bit?
Let's see.
As soon as you switch to code, Jess, I think is when we lost you.
Oh, my apologies. Let me rewind a little bit then. So I'll close this. What the nutshell version of this is: we're a business who our specialty is weather, and the reason I chose that is because it's the out-of-the-box Blazor template for a client-server app. This is not a Blazor talk. But I just chose that as a kind of a fun place to go. So we're not going to get into the Blazor details, but the point of this is that I wanted to be familiar to some folks, but also, provide an easy starting point. I know it's contrived, but, we're just going to pretend that we're weather specialists. And this application right now, all it does is it will generate random weather. So not very exciting. That's not the point. So life changes, the business grows. We start to have requests to expose our weather information to other people. So the geniuses that we decide to break our weather API into, like, our weather code into its own API. And that's what we've done here. So this application is the same application, but now we've now made the leap to our very first distributed application, right? So now our front end talks to the weather API across the network, across an HTTP endpoint. So big deal, not that exciting. I could easily manage this. I know probably some of you are cringing, like, oh my God, how can you have configuration of code? Don't worry about that. We're going to get rid of that in a minute, but I wanted to show you that pretend you had 1,000 of these and they all had different ports, you would quickly die in a fire of soulful pain and things of that nature, because it would be it's hard to manage. But we've made the leap now. We've actually made a distributed application. I'm not going to run this because it's the same app. It doesn't really matter. That's not exciting. But the point is we've now created a dependency between our front end and a new back end. So now life goes on, and then our business has the bright idea that we need to start managing people and the things people do. So because we've already started down the microservice pathway, we decided to create a person API and a to-do API. And those allow us to create and get to-dos and people. So we've now expanded the concept that we had before, where we now have this guy goes to 5007, and this guy goes to 5005, and this guy goes to 5003. And you can see where we're going here, right? We're now expanding. And yes, we could pull these down into config, but if you've worked in distributed mode, you know that port management can be an issue. You can have clashes with other projects that run on the same ports, and all that kind of stuff is just kind of annoying to have to maintain in an app settings file. So we have this. I'll run this real quick so you can see what the application looks like now. It's really not exciting. That's not the point of this, but we now have one front end that's talking to 3 nodes in the back end. So now we have the ability to add people. So I can add myself. All this is running in memory. There's no database yet. It's not that exciting, but we now have the ability to get our weather. We have people, and we have to-dos. Got it? Great. I know this is not exciting yet. Stay with me for one more demo, and then we'll get to the exciting part. So now the business, that green box we had at the beginning, whoever put the decision makers or short-term thinkers, they have said, you know what, guys? The idea of a person cannot exist anymore without the idea of a to-do, and the idea of a to-do cannot exist without weather. They have to go together. We have to sell those as packaged products. And they said you have 1 day to get that into production. So again, in our infinite wisdom, we decide, well, okay, we've got our person API, our to-do API, and our weather API. Let's just tie them together, right? Let's just make let's make person call to-do, and to-do will call weather. I mean, why not, right? So that's exactly what we've done here. So now we have, not only do we have this controller calling, these controllers down here are all making calls to the APIs like they were, but now we have our person controller makes a call to our to-do controller, or our to-do API, and our to-do API makes a call to our weather API. So you can see we've One, we've committed cardinal sin number one in microservice land, which is do not cross the streams. But everyone does it. Everyone does it because nobody wants to do the work involved with domain-driven design and defining your bounded context and creating different data stores. Nobody ever wants to do that. And nobody ever does because as we pointed out, there is a deadline. There's a deadline involved. So now we have all this kind of stuff that's spaghettified. We're starting to lose a little bit of context of like how all these things work together. A new developer coming in has to understand that if I'm a front-end developer, I have to know how the front end works, I have to know how person works, I have to know how to-do works, and I have to know how weather works just to get myself up and running. So we've created a situation which is a very tiny slice of what the real world looks like, where this blows up pretty quick. And it becomes very difficult to manage all those connections, to manage the endpoints between applications, to deal with, you know, how do I get myself up and running, and how do I know when I make a call from the person controller here, how am I supposed to know that that actually winds up chaining all the way down through to weather? Because it does now, right? It calls the person API, which calls the to API, which calls the weather API. How would I know that? I'd have to have intimate knowledge of all that stuff in order to debug this thing. So that's where life starts to get painful in distributed application space. It becomes an issue for managing your local environment, and it becomes difficult to figure out how to trace these things. So now we're going to get to the what you're here for, which is the tie component. So we're going to start with the number 5. So if you're following along in code, this is number 5. So I'm going to show you the most basic, simple, nothing of tie. This is cool, but it's like, it's not the exciting bit, but it's the beginning of the exciting bit. So I'm going to do tie run and show you what it does, and then I'm going to back out from that and show you how it works. So you'll ask yourself, you know, well, what is this? You just did this thing, and how did that work? Well, let me go here first. Actually, I already have it open. So I've run tie run, and now I get this thing. This is a dashboard that automatically comes along for the ride whenever you are running your distributed application in the context of tie. And I'll show you how it works in a minute. But the point is that if you do nothing else with tie and just run tie init, which I'll show you in a second, and then tie run, you will automatically get this, which will at least show you all of the pieces that are at play in your application, and it will give you sort of your console output in one spot. So each of these is essentially the console output of each of the applications. That's cool. It's not like amazing, but it's kind of cool. The other piece that you'll notice here is this. It will automatically create this set of things for you. So let me kill it and show you. So just so you know, we're at 64 whatever, right? So if I kill this and I run it again, you'll notice my dashboard disappeared because it's live connected. And if I refresh this thing, we're now at like 60, we're in the 80s now up here. So it automatically is creating ports for me. So that's one thing to keep in mind. So now when we go back into the code, we can see how this works. So let me show you, for example, one of our controllers. So we've introduced, just to make all of you who are cringing at the hard-coded ports and things in there, we've introduced a little bit of dependency injection so we can get our clients into our controllers from outside. And now the first magic of tie is this right here. So anybody that wants to access the person API or the to-do API or the weather API or anything else that's part of this application can call this extension method that's part of the tie space to get a service URI, and it will automatically give you this whatever URL that you're asking for. Now, how does that work? Well, basically, when you run tie init, it automatically creates this file for you. It creates the name. It does it. So if I go back here and I go, I'll delete tie.yaml, and then I'll do tie init and show you that what it does. So this one found so it just recreated this, and it actually found all the projects that are in my space. And you might think to yourself, well, it's like, well, anyone in the world can write a quick directory parser that can go out and find project files and stick it in a YAML file. Like, that's stupid, right? Who cares? Anybody can do that. Well, one, I'm going to get rid of this because we don't actually care about the client part. But what the important bit is is that behind the scenes, when you do tie run, it actually uses this information to do a whole bunch of Docker magic for you that will create all of that stuff that we just saw. And you don't even have to know that Docker even exists. And actually, in this case, it can do it without even using Docker because these things don't care about external dependencies. We'll get to that in a second. The point here is if you run tie init and then tie run, and that's all you do, you will at least get a dashboard that will tell you what's going on, and you no longer have to manage your connections, your endpoints from point A to point B. You no longer have to care if it's localhost 5003 or 5005 and all that other good stuff. Now that's, in and of itself, that saves time. That's not really like the really cool part of tie, but that's sort of the beginning of what you get with tie. So any questions so far about what I just did? Because I know that was kind of like, bleh, like here's a lot of stuff. So I anticipate there being some like, okay, where is this going? But any like, did I lose anybody or anything? I don't see any questions. So, okay. So now I'm going to show you what is really cool, which is the next one. Tie++ is what I called it. This is the same exact solution, same exact situation. But you notice this block up here, that's the only difference between 5 and 6, demo 5 and 6. And rather than explain to you what these are, I'm going to show you because they're pretty freaking cool. I'm going to run this thing, and I'll show you what happens. So first, you'll see, hang on, let me scroll up here. First, you're going to see some Docker stuff. So tie has recognized that we've asked it to do two special things. We want it to run Zipkin, and we want it to run Elasticstack. Tie will automatically, assuming you have Docker installed, it will automatically go get your images, set up the ingresses, and get them hooked up to your environment to get them to work. So what do these two things do? Well, they do some pretty amazing things. So first, you're going to notice we've got two new nodes in here, a Zipkin and an Elastic. And Zipkin and Elastic together provide, this is the first part of tie that was like, okay, this is magic. This is truly magic. So let me show you what this does, because it's better to see it than to just hear about it. So I'm going to load this thing up again, and I'm going to make some requests to just do some stuff. I'm going to generate some traffic because I need that to show you what these two things do. So I'm going to add some to-dos. I'm going to add one more. It doesn't really matter. I'm going to add some more to-dos. I'll add one more person. I'll just add myself again. I'll browse around and, generating some traffic. That's all I'm doing here. So now I'm going to go back to Zipkin and show you. If you haven't seen Zipkin, this should excite you, I hope. So Zipkin is a distributed tracing tool. It is usually very difficult to set up. It usually is not available locally because it's difficult to set up. And it provides you this. So just by getting the Zipkin thing as part of my tie YAML and generating traffic, I now have the ability to see distributed trace information for my application. So I can run this and I can see, okay, I don't know anything about this application, but apparently when I call person, I actually wind up calling to do, and then I actually wind up calling weather. And apparently there's some time in here that I might want to look at because that's kind of a big chunk of my time. And this guy is pretty big, so maybe I need to figure it out. It gives you that information. That's cool. This is really cool. This is a live graph of what's happening in your system as it's happening. So I can tell by highlighting these nodes, I can tell what they talk to, because I can see, okay, front end is calling API weather, front end is calling person, front end is calling to do, person's calling to do is calling weather, and I can see all this stuff in it built this for me. Like there was no pre-knowledge of this. And you can use this, because we're terrible at creating documentation, you can use this to live create your sort of application dependency graph. So imagine if you had 1,000 microservices. No one's going to maintain that, and especially if those are crossing team boundaries. But with this, you can see everything that's going on. And if you are having issues, you can actually see, okay, if I had, let's say that this was happening, and this is happening, and this is happening. If I see stuff going this way, I can tell I've got a circular dependency going on. So it can help you with those kinds of things as well. And all of this is happy path. But if I go back into here, you can actually see like, you know, let's say I had problems. It'll show you like this one isn't a normal 200 because it's a redirect because of the way the API is set up. So it'll show you what happened at each node too. So it'll tell you we have problems, and it's like I said, the magic here is that literally all I did was that. I did nothing else. I had to do no setup. I had to do no anything else, and it automatically set that up for me. The other one that Ty gives you out of the box is full elastic stack. So that one is for those of you who are Elastic or Splunk folks. It's a log aggregator. So I now have in my local environment my own completely self-contained, uncontaminated, fresh set of just all the logs from all my applications, and I can start doing things like, you know, I only want to see my weather logs, or I only want to see my to-do logs, or whatever it is. Again, this is not a tutorial on Elastic, but if you're used to having a log aggregator, having it locally and having it be uncontaminated by other people's information is huge, and it's usually very difficult to do. And again, this gets spooled up and torn down every single time you run Ty. So with minimal, very minimal effort, you now have the ability to trace and log aggregate across your entire application space by doing nothing other than essentially using Ty. So that was the first piece where I'm like, okay, this is something that I really need to pay attention to. When I saw this, I'm like, okay, this is important. So this is like the first slice of Ty, which is you have the ability to bring your services together, put them in a dashboard, and then also get distributed tracing and logging with only a few commands. So any questions on this before I kind of take us into level 2? Because this is still kind of the baseline stuff.
Yeah, I have a question. So as you were showing that, like going back to Zipkin, for example, you had, I think it was trace IDs that were associated with kind of the entire session there. So if that's being auto kind of added into your projects by Ty, do they somehow have a way of exposing that stuff to your application? So like if I wanted to throw an exception and have the trace ID in there or something like that. I guess I'm asking more from a big picture perspective and not just Zipkin, but when it does this kind of injecting, is there some kind of way of exposing things from those containers?
Zipkin is more of it's an examiner. If you want sort of a correlation ID, at least from a .NET space, that's sort of built in these days. So like if you look at these logs, most of these should have, I don't think I turn it off. Like you can get like request ID is one of them, but there are correlation IDs that you can just set up within the new in .NET Core and .NET 5. I'm not sure if that's really answering your question. I think the short answer is Zipkin will not give you that. You can't really get that back into the application, but your application, if you're doing .NET, your application can certainly emit that into the ambient request, and it can get picked up by everyone down the stream as long as they're also in .NET space. That said, there's no reason that you can't run Zipkin in production or any other environment to provide you this level of insight in your running environments, because it's not like there's very minimal performance overhead, so you could use this if you wanted to beyond your local environment. But I guess hopefully that more or less answers what you're asking. I'm not really,
Yeah, I guess what I was getting at is, there's stuff that's coming along for the ride with these extensions that you're putting in. And is there a way for the extension to feed that back into, whether it's injection or some other method, pulling that back into your individual services?
Yeah, not these guys, because these guys are only receivers of that information. They don't emit back in.
Got it. Okay.
I do think I do think that Zipkin can feed into Elastic. I believe that's actually, if you wanted to set that up, that's actually a good point. Maybe I should look at that in the future. But you can add Zipkin as a known source. That might be the way to do it, so that your Zipkin is emitting into your log aggregator. That's probably the best way to do that, actually. Any other questions about sort of any of the stuff we've seen so far before I go to the next thing that will hopefully blow your mind a little bit? All right, so let me close these out. And now I'm going to show you one thing that I wish they would fix, but they still haven't gotten around to fixing it, which is when I kill Ty so when you do this, or when you use actual Docker containers in your Ty space, it will create an actual network within Docker. There is a race condition that's logged as an issue in the Ty repository right now, that when you have the dashboard open, you get this error because the dashboard runs on SignalR, and it keeps a connection open that prevents the Ty shutdown command from killing the network before the SignalR lets go of it. So if you see this when you kill your Ty, it's just because of that. It's because you had your dashboard open. It doesn't leave anything out there. It doesn't not clean up after itself. It's just they need to figure out how to fix that error from happening, but it doesn't mean anything terrible happens. So just be aware of that. If you're in Docker space in Ty, you're going to see this if you've got your dashboard open. So just be aware of that little thing. I don't know why they haven't fixed it. It seems like it should be something easy. And instead of complaining about it, I should probably just submit a PR for it, but I'm too lazy. So the next thing is easy mode Docker. So a lot of you said that you're not like super expert at Docker. I would raise my hand and say that I am also not super expert at Docker. So what I'm going to show you now is how to go from not knowing anything about Docker. And I'm a new developer in this space, and the business has decided for some reason that we all also now care about students. So we're all over the place in terms of our business domains, but the students live in a SQL server. So now we're bringing a SQL server into our application. And for anyone who's ever done an application development, any real application development, distributed or not, setting up a database locally sucks. It always sucks. There have been various attempts to make that easier, but this one I'm about to show you is like super easy, and it basically just relies on Ty to set up the image, and Entity Framework migrations to seed your database. So what I'm about to show you is an application that needs a database. I don't have SQL Server installed. I don't want to install SQL. I don't want to pollute my machine with SQL Server. I just want to go and change something in, let's say, the university API. How do I do that? So it's pretty simple. The only thing you need to know to make this work, so you'll see we now have a new project in here, and we also now have a Docker image in here. So this right here is as far as you need to understand Docker. And you don't really even need to understand this. All you need to know is, just like npm or just like a NuGet or any of these other repositories of common libraries, just familiarize yourself with Docker Hub. And if you think something exists if something should exist as an image, it probably already does. So in order to make this work, all I did is I went out there and I looked for SQL Server, and I said, oh, look, there's an official SQL Server image for Microsoft. And I need to know two things. I need to know this name, and I need to know any of the required environment variables to set to run a Docker image. So ignore all this. All you need to know is the name of it, and the fact that you essentially need to set these two variables, and maybe this one if you don't want the developer license. I don't care what license it is, so I just left this one alone. So you'll see here, I copied this and I copied these two values, and you're going to see them. They're right here. That's the image name, that's variable 1, and that's variable 2. That's as far as you need to understand Docker. You don't need to understand anything else, just what do I need to do to make this thing, the minimal configuration to make this thing work. And then up here is, I told Ty to give me back a connection string that's going to work with .NET. So that's what this line is. It's like, give me a connection string that is going to work with Entity Framework, and whatever host and port you give it, just give that back to me. And very similar to the get service URI, we also now have the ability to just give me a connection string, give me the Usador connection string right here. So by this name, if that exists, give it to me. That's what we're doing here. So this is the other half of the Thai code. There are only two functions in Thai that you use in code: get service URI and get connection string. And you'll also notice, just in case you're worried, this is kind of how you back out of Thai. So if you don't want to get married to Thai, you can do this. And if this doesn't work, you can always just fall back. If it's null, you can always just fall back to the old way of doing it. So you're not locked in. You just have to decide which way you want to go, and it provides some sort of fallback mechanism to the old way of configuring. So that's all well and good, but the magic here is essentially, if I run this thing, which I'm going to do, you will see, once again, you will see that we've got another Docker image now. It's going out and it's going to get SQL Server. I already have it, but if you didn't have it, it would download it. It throws it into an image, and it also, we still got Zipkin and Elastic. And now if we head over to our dashboard, we now have SQL Server. And this is a full-fledged actual SQL Server. So I am going to connect to it real quick and show you that this is, I have now gone from 0 to hero, and I'm going to delete this in a second to show you what this does. But I now have a SQL Server, and if I go look, if I refresh this, I should get, let me go back into here, make sure that it's because I was having it locked. If I go back into here and I refresh this thing, hopefully, so it created my database that I want, it created the tables I need, and it put data in them as well. So I have, every time I run my app, if I run it through Thai, I have a brand new database with seeded data with known conditions, and I have full access to it through SSMS. It's a database. But if I kill this, if I tear this down, and I refresh this guy, it's gone. Like that database doesn't exist. I didn't install SQL Server. I didn't do anything. So now I'm toast, right? I don't have SQL. So I'm not toast, but like I've cleaned up after myself and I'm done. So again, that's a combination of a few things, but the main one is I told it I wanted SQL Server. I told my API to use the service name from Thai to get the connection string. And I used, this is sort of out of the scope of this talk, but I used database migrations to get me up to where I need to be in terms of where the data lives, in terms of where I am in the data lifecycle. The other thing to keep in mind, you might be asking yourself, is if I tear this bad boy down every time, how do I actually persist my development from run 1 to run 2? Like if I'm changing a store procedure or if I'm adding a table, how do I make sure that stays there? All you really need to do is just, this is the only other little bit of Docker you need to understand, is make sure that you can just have a volume and it will persist your SQL Server data, but not the SQL Server itself, to a virtual volume in Docker. So if I were to uncomment this and I ran the thing and I ran it again, it would not re-migrate me because it would already have been at that position. So you have the ability to either be fully clean every time or clean it once and then keep the data for your next runs. It's totally up to you. This here, again, the power here is that, any one of you could come onto my team and be up and running my application in 30 seconds. That's all. You don't have to set up SQL. You don't have to do anything. You just have to run this and go. So while we're here, I want to. My question was, so that's all well and good at runtime, but how do I make changes and debug this crap in a way that works with the way I'm used to using Visual Studio? So essentially, how do I change things at runtime? And there are two ways to do it. The first way is the least elegant way, but gives you the most flexibility. And the second way is a little less elegant, but lets you kind of move quickly from change to change. So I'm going to show you both, but I want you to be aware that this is a space that the Microsoft folks know. This is the piece that they, I think, are stuck the most on, because changing Visual Studio requires a whole lot more checks and balances in Microsoft than adding a new tool like Tye just to, you know, your .NET space. So they're working on a way to make this a first. Basically, they're working on a way to have a button that's like run with Tye or debug with Tye, but they don't have that yet because they have to sort of figure out where they're going with Tye before they can go through the whole PR process to get something into Visual Studio. So the two ways to do this. Way number one is Tye, run, debug, everything. That's way number one. So if I do that, it's going to do the same thing as before, but it's not going to launch anything until I attach a debugger. So this part's kind of ugly and gross, and I don't like it. But this is if you're in Visual Studio, this is your only option for the moment to debug, which is essentially just attaching the process. So I recognize that that's annoying, but it is what it is. So when you run this, you get these, you get your processes. I'm going to attach to them, and let's just do, for the heck of it, we'll go to our person API just to show you how it works. It's nothing magical here, but if I throw this in here and I go back to my dashboard and I hit the person API and I bring up the Swagger endpoint and I pop in blah, blah, this one, and I try it out, I run it, I'm at my breakpoint. So not sexy, not a great experience. They know that, they're working on it. On the flip side, they're also working, if you're a VS Code person, they're working on a VS Code extension that makes this essentially run with Tye. They're making that. For some reason, they haven't released it even into pre-release yet, which is annoying, but there will be that coming. So they will have both options available. So this is one way to do it that I find it's only really useful if you actually need to truly set breakpoints and debug things. What I found myself doing more often, though, is I just want to see runtime changes. So let's say I'm in my front, let's say I'm in, I don't know, let's say I'm in the person API, and I already know what I want to change. I don't care about debugging it. I just want to see what at runtime I want to see that change without having to kill Tye, rebuild, rerun Tye. It provides this other option that they called watch, which is what it sounds like. It will watch the files in your projects, and if there are changes, it will drop the image, rebuild it, and put it back in place in a way that you don't have to worry about. So let me make sure this thing spools up real quick. Okay, so just to show you how this works, and then we'll move on. If I go here and I say, okay, let me change this. I'm gonna change that to 1.1 just to demonstrate how this works. It's not a really interesting change, but this is what I wind up doing more often than actually like attaching. So I'm gonna go here, I'm gonna just change this to 1.1. Save it, and if I go back to here, you can see that it detected a change to API person and it injected a new version of it. And if I go back to here and I refresh this, I'm at 1.1. So that's how I most often am using Tye, just so you guys know. It seems to be a lot, like I mean, I don't know how it's up to your personal style, but most of the time I don't need breakpoints. I test that kind of stuff with unit tests, but when I want to run at runtime, I just want to make a change and see it happen out here. I don't really care about debugging. You can do both at once, but as soon as you make if you attach to person and you make a change to person, it's going to kill the person process and you're going to lose your debugger anyway. So there's really you can't really run them both at the same time effectively, but they are kind of cross-compatible. So anyway, that's how you currently work through the runtime process of Tye if you want to make code changes. That is the feature that I think they are most concerned about making better, because that's not exactly the greatest, but it does work. So really quickly, before I move on, any questions about anything that we've just seen? I'm happy to take a break here and stop for a second, because I know we're kind of just going full speed ahead. If not, I want to show you, just so you guys can see it, I want to show you the Superman version of what I just showed you, because I think it's kind of cool. When I did it, I'm like, yeah, this is kind of neat. All right, so we're going to take a quick diversion. We're going to skip.
Hey, Jess, a quick question.
Yep.
Yep. So as you talked about earlier about like eventually these APIs all get split out into their own projects. How do you handle this cross solution? Like if you just pull in all the solutions and run Thai?
Yes, you've asked the question that's going to be the payoff at the end of this. So stick with me to the last demo,
Okay.
and you will see, because that is truly, that's the problem, right? That's where you want to get to. You want to have everyone have their own repository, but you don't want to have to go run 57 different solutions to get everything up and running. So we're going to get there in a minute. So let me hop forward to, I'm going to skip 8 for a second, and I'm going to show you this one because I think it's kind of cool. So this is a super, super ultra contrived demo that allows you to go from 0 to having a SQL server, a Postgres server, a MySQL server, a MariaDB, a MongoDB, Redis, and all the admin tools needed to do that with just a bit more of the same basic magic. So we've now got a bunch of garbage APIs. Each one of these sits on top of some other new database. Like this one uses Mongo, and this one uses MySQL, and this one uses Maria, whatever. But the same basic principle that we applied here applies to anything that you can put into an image, into a container, I should say. So we've got Postgres, we've got MySQL, we've got Maria, we've got Mongo, we've got Adminer for doing a PHP administrative interface for some of the databases. We've got Mongo Express to admin Mongo. We've got Redis, and we've got Redis admin. All of these things, essentially, the reason I did this is I want you to understand the way I feel about it is you basically get like a baby cloud with Thai, because you could do all these things in Azure, but it would be kind of a pain in the butt to spool this up just for yourself. Like you could do ARM templates and get all that stuff up and running, but wouldn't it be easier just to go this and Thai run, which is exactly what I'm going to do here, and it works just like you'd hope it would work. It does exactly. Oops, we don't want 8, we want 9. And we won't spend too long on this, but I just want to show you that it truly does work. And it's like, okay, I can do anything now. As long as there's a container out there, I can make all this stuff work. So you can see I've got all of this stuff now. I've got, Mongo, Maria, Redis, all that stuff's here. And it's all here. So I've got all of my stuff going here. I can hop over to I can get to my Redis commander right now, so I can see what's going on in my local Redis. I can hop over to my Mongo. Oops, that's the wrong one. I can hop over to this guy, and I can admin my Bird API. I can do anything I want as long as I have the imagery. And what's important here is that Thai, because it does all the Docker stuff for you, all of this stuff exists in one giant Docker network. So all of this stuff plays together. And again, you don't have to care about any of this stuff. All of these connections, they're just handled by Thai. So you can have all these databases, all these microservices, and it's all just follows the exact same pattern. So when I pull up, when I look at any of these guys, like API hat now, they all use the same pattern, right? Give me the connection string for wherever it is. Give me the Postgres service. They all use exactly the same pattern across the board, and they all work perfectly well. So if I actually go to my front end server, I can see, okay, I'm going to have a whole bunch more stuff on the left here. This guy is coming from Maria. This guy is coming from Postgres. This guy's coming from Mongo. This guy's coming from MySQL. This guy's coming from SQL Server. And they all just work. It's like magic, right? Like that's crazy to be able to go from nothing to 1,000 databases, and I don't care. And as soon as I shut this down, all those resources are gone. Everything is out of my hair. I haven't just used up 900,000 CPU cycles all the time because I have all this stuff running. It's all gone now. So it's super, like I said, it's kind of like a baby cloud that you can just spool up and down without caring about Kubernetes and Docker. So any questions about that? That was basically just like the wow factor version of what you can really do with the containers. I'm going to take a quick sideways diversion to show you one other thing that Thai does that is really, really hard to test in the non-Thai world. And that's...
Hey, Jess, one other question. With when you're spinning up all those different Docker containers, when you're looking to have persistent storage, is that per container? Or can you set it up that each of these containers that I'm creating, I want to use the same storage?
It's up to you. Yeah, it's totally up to, like if you target the same volumes, you can definitely you could store everything in like opt data storage or something.
Right.
And just
so you do one for all or split up per
whatever
depending on what you want to do.
Yep, whatever floats your boat in terms of what works in your environment. Yep.
Cool.
So this last, it's not the last demo, but it's the last sort of like bit that we're going to talk about in terms of what the native Thai stuff does. Anybody who's worked in a distributed application environment has probably been bitten by a class of bugs that I call, they're load balancing bugs, right? So you've got a bug that only represents or only presents itself in your environment where you've got 5 web servers running the same app. And you're like, what the hell's going on? And you got to connect, you either got to like remote debug out into your dev environment or you got to get through the firewall, through the load balancer to be able to figure out why is it sometimes working and sometimes not. Well, Thai lets you do that just by adding this line. You can add load balancing to your local environment and hide it behind an ingress. And if you don't know what that means, it doesn't matter. It just means hide it behind a virtual load balancer. Just by saying, give me 3 replicas of the university API or whatever you want to do. So this demo, real quick, all I'm going to do here is just show you how it works, just to make sure you understand like the basics of it. What I've introduced in this space is a super simple example of a distributed bug, which is essentially we've got this controller that holds onto a static date, and anybody who asks for that date should get the date back. But as soon as you have more than one instance, you've got more than one variable of the date, right? That's the problem. The point here being, I'm not going to show you how to fix the problem because you could do that any number of ways. I just want to show you that you can reproduce the problem simply by doing replicas. So if I hop back over to this, and I'll do this quickly because I know this isn't super interesting, but it's very helpful when you're dealing with these kinds of bugs because you can't normally reproduce this. So the first thing that we're going to do is I'm just going to hop back into the dashboard, our friend the dashboard here, and you'll notice this here. By default, you just get 1, but now we've got 3 of our university APIs. So if I come over here and I go to, let me pick up the port real quick, 1192. So if I go here and I'm going to just run a curl to that URL. 11, what was it, 92. So you're going to see that the dates are going to, here, let me clear this. You're going to see that the dates cycle between 3 values. Because I'm round robin, I'm now load balanced round robin locally between 3 instances of my API there, right? So I've got 3 different dates, and if I go here and I actually run the post on it, if let's say I update this thing and I'm going to set it to, let's just set it to 2021-05-01. We're going to do that. We can see, just to drive home the point, if I clear this out again, oops, and I run this, one of them is going to give me that date and the other ones are not. So the point here is just that this may seem like, oh, that's silly, but that's almost impossible to produce locally without some heavy-duty magic helping you create a local load balancer. So if you've ever dealt with a distributed application, you've probably dealt with this kind of bug where like you've got a distributed cache that's screwing you or something isn't working and you just need to figure that out and you can't because you can't run 5 instances. Well, now you can. So that's really what this one's about. So like I said, that's sort of just an aside. And again, all you have to do to make that work is pop in some replicas, however many you want, and you're off to the races. So the last couple here are a little bit different. One is deploying to Kubernetes, and one is the question that Kevin asked of, so what do we do when we grow up and become, big boys and girls and actually have properly structured repositories? As I mentioned to the people who were here at the beginning, I screwed something up and accidentally deleted my ingress on my Azure Kubernetes service, and it takes like it's like a 20-minute thing to requisition a new one. So I can't make one for you right now. So I can show you that it will deploy and package, but I can't show you the, hey, everyone can go hit this API because I got a public ingress out there. So real quick, I'm going to show you right now. I have in my AKS space out in my enterprise subscription, I have my person to do in weather and my front end. So I'm gonna go out here and I'm gonna talk through a few things because this is where it gets a little weird. So first I'm gonna undeploy, which may or may not work. I'm not sure if I'm authenticated, but we'll see. Okay, so I've done that and I've killed all of my resources from my application. So I'm back to nothing. So let me rewind really quickly. Let me rewind back to, is this it? No. Let me open the solution. Here we go. So there's two very important pieces to remember if you're going to try to leverage this with Thai. The most important is that Thai cannot and will not probably ever deploy your external dependencies to Kubernetes for you. If you don't know what that means and you don't know Kubernetes, think of it as Thai will essentially package and deploy your code, but it will not deploy the things your code depends on, mostly because it's dangerous, because you don't really necessarily want your baby version of Thai configuration to be your production configuration for your SQL Server or your Redis or whatever. So these are external dependencies. The databases are external dependencies. Thai will not, again, it will not and cannot package those for you, and that's unlikely to change. So just keep that in mind if you want to use this for deployment. Second, it will detect your dependencies and it will ask you for the connection strings to those dependencies so that it can create secrets for them. So it will at least configure your Kubernetes in a way that is secure. It just will not bring along these for the ride. So like I said, this is really quite basic. All you really need to do is Thai deploy. And I'm going to do it interactive, so it prompts for things. But this will, assuming I'm still logged in, I think I must be. It will actually, I don't know why they chose, this is okay. They chose red as the log color because they're insane. I don't know. The first couple, I'm like, what is going on here? This is all fine. But somebody has a sick sense of humor, I guess, and decided that red is the right thing for normal logs. But what you're seeing here is it's actually Dockerizing my person service, and it's publishing it out to the store, and it's asking me, okay, I know that you need Zipkin and I know that you need Elastic. What is your AKS URL for those? So I'm just going to put in anything. It doesn't really matter because these aren't real. But you can see it creates a binding, a secret binding for it, so that, or a secret for the binding, so that it's securely pointing to whatever it needs to be. So in the real world, those of you who are DevOps folks would be in charge of creating the actual SQL Server or whatever it is out there. And then, you can tell the developers, or you yourself can enter the right things in here. But right now, I'm just going to, put these out and see whatever it is. So again, we're Dockerizing to-do, we're Dockerizing weather, we're Dockerizing the front end, and then it pushes the stuff out, and it keeps looking like it's failing because it's all red and blah, blah, blah. But it works. And this part here, it takes a minute because it's like, I expect you to have an actual working ingress out there. And like I said, I don't. So this is going to, eventually it'll say, hey, it worked, but it really didn't. But the point is, with that one command, I now have Dockerized my, I've now containerized my person, my to-do, and my weather API and my server. And if my ingress was working, I would actually have a public IP for it, and you could all go out and hit it. So the point there is, 1, Thai will not deploy your dependencies. 2, it will ask you for secrets for those dependencies. And 3, the one I actually forgot to mention is, Most people don't use this. According to the Thai community or the Thai developers, almost nobody gets to here. They use it for all the other stuff we've seen, but they don't use this. So my guess would be, whatever this winds up being in .NET 6, the containerization and the Kubernetesization, the Kubernetes aspect of this may be split out from Thai in a way that makes them sort of two parallel products that don't necessarily have to go together. But anyway, if you need to quickly get to Kubernetes to show your IT director that you can do it, or if you need to quickly demonstrate that this can work, this is the easiest way I've ever seen to get out to Kubernetes. This will work with any Kubernetes container space. It works with AWS. It works with GCS. It'll work with a local one. It doesn't have to be AKS. It's just you need to give it the right information for where you want it to go, but it'll go there. So that's kind of all there is to this. Like I said, the cool part is when this actually is hittable out in the public, but I screwed that up, so my bad. The last little bit, this is the sort of how to tie all this stuff together in a way that is grown up. So I'm getting back to our application space. The multi-repo it's one repo, but each of these things has its own solution under it. So if I go here, I got a front-end solution. If I go here, I got an API weather solution, and so on and so forth. This emulates what you should have when you graduate to full distributed application. I know how to use Git. I know how to structure my solutions in a way that they all have their own space to play, and everybody can make, I don't have to load up 50 different APIs into one solution. So that's where we're at here. So each one of these, if I open up birds, let's say, each one of these has now been split to have its own Thai YAML file. So each one of these is a standalone. So the birds API uses Zipkin. They all use Zipkin and Elastic. This one happens to use Mongo. The next one has SQL Server. The next one's whatever. But each one has its own Thai YAML that's designed for it to run itself. So the question is, okay, my front end uses all of these, and some of them use each other. I think Kevin asked, like, how do I deal with that? Like, how do I not have to, deal with the fact that I need to know about all this other stuff from my front end? And the answer is, it's pretty easy. So I'm going to open my front end because that's the guy that uses everything. This is what you do right here. So you essentially can chain YAML files together, and if I go into my front end, and I do Thai run, this takes a little bit of time now because it has to go through all of them and then through all the dependencies and so on and so forth. But this will create the entirety of the universe for this application. So it will actually create everything, but it only knows about itself and its level 1 dependencies. So it's basically, I know that I will need to use the bird API, but I don't care how it's set up. Just go figure out how to load that up. And the bird API says, well, I know that I need the, I don't know, let's say the hat API. It doesn't, but let's say it did. Go create that for me and do all that other stuff. So that's how this works. And this does work in the context of debug and watch as well. So if you need to go change your front end, that's easy. But if you need to change weather as well, you can just have it be watching, and you can go change weather, and you can change front end, you can change anything you want, and all these things will just respin themselves up, and you're good to go. And Zipkin and Elastic will play together, and like if I load up, it should be transparent to the user, right? So if I load all these things up and I hit every single endpoint, I should, assuming I'm not a liar, which has been known to happen. If I load up Zipkin, for example, I hopefully should see a whole bunch of nodes now, right? So all of it still works, and you'll note that every single one of these uses Zipkin and Elastic, but Thai is smart enough to not create 15 Elastic Stacks and 15 Zipkins. It knows I only want the one in my environment. I don't want 10 Zipkins. I want the one to do all that together. So this is essentially, like I said, if you're building each one of those microservices and you're building consumers, if you drink the Thai Kool-Aid, you will have set those up to have their Thai YAMLs. And really all you need to do is point to a dependencies Thai YAML and you're good to go. So it's almost a little tiny bit like Docker Compose. But anyway, that's essentially how you do it. So to drive home the point, just really quickly, let me kill this thing. Wait a second. I'm going to show you, just so you don't have to take it on faith. If you were to go into any of the downstream APIs or anything like that, come on. Sorry, there's a lot of stuff here. Where I'm going with that is if you go into like API birds and do Thai run, it will just do it'll just do the birds API. So each one of these things is fully independent in and of itself, but each one can be tied together with a Thai YAML. So anyway, I think I've kind of beaten that horse to death. So that kind of takes us back to a bit of a recap. So before I open the floor to comments and questions, I want to just run through some that I get asked a lot. So this one we talked about. So you have the two options for debugging. That's how you do it. I'm not going to go over this again. I've been asked a couple times, if you go into the code and you look at it, people have asked me, like, why is your business like where's authentication? Where's persistence and things like that? The answer is this is not a demo for how to structure an application with all that kind of stuff. It's a good question. Like in theory, I would like to have time to do that, but that's not what this demo is about. So please keep in mind, if you go look at this code, don't use it as this is amazing code for I can do everything with the code. This is to show you how to plug things together in a distributed application space with Thai. I'd like to be able to go in and fix it or make that better, but that's really not part of what this is. So that's kind of why if you dig deep into it, you're like, okay, there's not a lot here. Well, it's true. It's because these applications are, they're garbage. They're not real applications. They're just there to show you some of these other points. These questions have been asked about Zipkin. So I've been asked if Zipkin should run in production. The answer is yeah, if you want to, sure. Zipkin doesn't have a huge performance hit. It really just it's kind of like a network sniffer almost. So yeah, go for it if you want it. People have compared Jaeger to Zipkin. You could certainly run Jaeger if you don't. Jaeger is kind of like Zipkin, but it requires it's just a little bit of a different beast, and it's not something that is like a one-liner with Thai. So the reason Zipkin is here is because you literally just put in give me Zipkin, you're off to the races. If you want to use the Jaeger container, you certainly can do it. And then I think we talked about this before, actually. If you want to write your Zipkin logs to Elastic, you certainly can. But locally, there's probably not a whole lot of value in that. Moving on from that, I've been asked about Thai versus Zookeeper. Zookeeper, if you want to know, it's basically an Apache licensed sort of mega version of distributed application configuration information. You can certainly use it in place of Thai, but you're not going to get up and running in this lifetime. It's going to take you a lot of effort to get that up and running locally, and it's just not as easy in the .NET space. Now, if you're in sort of a mixed mode application environment where you have like Java and I don't know, PHP and other stuff, maybe that's something worth looking at. But Thai is Zookeeper on steroids when it comes to .NET because it's just so much easier to deal with. You can use them together, but I don't know why you would. And I can't really tell you much more because I'm not a Zookeeper expert. And then finally, these are some of the other things we talked about, like, why I didn't go deep on Blazor. It's not a Blazor talk. Why didn't I do authentication? It's not an authentication talk. I know that's kind of a cop-out answer, but these are the real reasons. I would like to go deep on Dapper with this talk, but this talk winds up taking so long that there usually isn't time. Dapper and Thai are being developed by the same people, some of the same people. So they work natively together. So there is another talk that one of my Polaris buddies does on the Dapper side of things. So that is available if you guys ever want to hear about Dapper. It's a complementary technology to Thai. They kind of go together, but they don't do the same thing. And then just keep in mind that Thai is experimental. So if you use it, there is a chance that it could go bye-bye, and then you'll be sad, and then you'll have to figure something else out. But for now, they have committed to supporting it. And so yeah, let me wrap it up. So we've seen service discovery. That's just Thai in it. We've seen, if you don't know about Docker or Kubernetes, you can still use containers. It's really easy to do. Get familiar with Docker Hub if you want an easy way to get into Docker. This is probably the easiest way to do it. Just start playing with Docker images by throwing them in your Thai YAML. You don't even have to worry about how the Docker stuff works. Just throw them in there. Monitoring with the dashboard and Zipkin and Elastic, super powerful, super easy. If you want to go out in the adventure of making clean databases, you've got that option. The code's out there for basically all of the main sort of common DBMSs. It's out there in example number 9 or whatever it was. And if you need to do load balancing deployment, that's an option too. So, oh yeah, sorry, I got to tell you this. If you're interested, Polaris can do all this stuff for you. We're all kind of like, everybody's a little bit like me where we like to nerd out on this stuff. So I love to talk about this. If anybody has any questions or comments that you think about after this, feel free to email me. That'll be at the end. If anybody wants to talk about this in more of a service provider perspective, we can certainly help there. And there's going to be one more question on Menti. I'm going to pull that up now, and you guys can just answer it as we go here. If there's anything that you guys can think of to help me improve this talk, or to help me, just something that was stupid or whatever, throw it in here, and I'll try to incorporate it into if I give this talk again. But with that said, it's kind of back to you guys. Does anybody have any interesting thoughts or questions or comments or concerns? Am I crazy? Is this cool? Is this stupid?
I think it is amazing, and certainly probably the easiest way I agree that I've ever seen something deployed to Kubernetes. When you're running this locally, what are, besides .NET itself, are there any other requirements? Do you need to have Docker? Do you need to have Kubernetes or Minikube or anything like that?
If you want to use containers, you have to have Docker.
Sure.
If you just want to tie together your code, you do not need Docker. If you want to, I think I actually pulled it up. It's in here. If you want to run these demos, you will need .NET 5 if you haven't installed it yet, because I just use this as a place to do that. That's not a requirement of Thai though. Thai doesn't care if it's .NET 5. I don't know that it works with .NET Framework, but if you're still in .NET Framework, I would be sad.
You're probably not running in containers in Kubernetes. Yeah.
You're probably stuck in a place where you've got a lot of other different problems before you get to something like Thai. If you're using anything with containers, you'll need to install Docker Desktop. If you want to use Kubernetes, you will need a cluster to deploy to. AKS is the one we used, but if not, you just need somewhere to put it. And then you just need kubectl, and for the Azure stuff, you need the Azure CLI utility. But if you have your own cluster already, all you need is kubectl, and you're good to go. So yeah, it just depends on what you need to use. In the simplest case, you just need Thai. And I don't know that I did it in the README here, but if I didn't, which I probably should have, let me see here. Yeah, so you can follow this to get Thai installed. It's just a tool that you can just install through PowerShell or whatever. You can also just go to the Thai repository and use their directions. Just so you know, there is more to Thai that I haven't it's in development. So like, for example, if you go to their docs, they've got things like if you want to use Azure Functions, that's something that you can now do with Thai locally. You can also use, there's a way to use GitHub Actions to essentially do what I was doing through the command line to get your stuff out to AKS. So there's other stuff, and this thing is always growing. So if you really care about this, I would just kind of keep an eye on this every week or so, just see what they're doing out here, because it's a moving target in terms of, so far they haven't ever removed functionality. It's always additive, but it is changing. So yeah. Anybody see any like pitfalls with this? Anybody scared about this? Like where there's like no way we could use this? Are there any DevOps folks out there who think that this is going to cannibalize their job or anything like that?
Well, one question I had is if you're using like let's say log analytics and app insights in production, how do you use the Elastic and everything locally and still use what the other stuff in prod? How do you handle that configuration?
So like the difference between having app insights and all the mega cloud stuff versus locally. I mean, basically, I think it's up to you. If you want to have Zipkin in your prod environment, get it out there. But none of this stuff gets in the way of or precludes you from using your normal log ingestion, like app insights, for example. Like it's almost in the simple case, it's basically like Zipkin and Elastic give you a simplified version of app insights locally. That's really what it is. And then when you can deploy, you can go back into the big boy mode of actually having real app insights and stuff like that. So nothing in here, nothing in Thai, unless you use Thai deploy, it doesn't impact your builds or your deployments at all. So it's not going to change any of your application insight settings or targets or any of that stuff.
Okay.
It just kind of eats that stuff up locally, but once you run it through your build pipeline, it doesn't know anything about Thai.
So as long as you're not using the key part is as long as you're not using Thai deploy, you won't run into an issue. Gotcha.
Yes, and even if you do use Thai deploy, I still don't think you'd run into an issue unless you were trying to, like, I don't know, target Elastic in production, and then you have to mess with that. But if you're just going to go with app insights and things, I think you're good to go in that space, at least with respect to Azure. I am not.
So you'd have a separate production like Thai file or whatever that's called, the Thai YAML. You'd have one that excluded those extensions then when you're doing the
it doesn't deploy
the deploy.
the third-party dependencies, so you wouldn't have to worry about them coming with.
Okay.
Right. Yeah, it will not. So if we pull like this guy, if we were to deploy this, it would only deploy these, and it would ask you, where do I need to point to get to these, but it won't deploy these. So you're safe from sort of the infrastructure when you do a deploy using Thai deploy. And if you don't use Thai deploy, nothing in here matters at all, actually.
Okay.
What I'd like to see them take Thai into a space that is more targeted at the ops side of DevOps, but so far they haven't done that, because I think they could. In my experience, there's often tension between dev and ops, even though it's supposed to be one thing. So it would be nice to have a tool that lets people play together, or encourages people to play together. But so far they haven't really gone that route yet. So yeah, I don't think there's. There's nothing else. This is me. If you want to get to me, any of these options work. Well, not this one. That's just Polaris. But these two, if you want to get to me, probably email's the easiest way. I do